before we move on to example 7C, there's something I forgot to mention when we did examples 7A and 7B. Notice that we were actually multiplying the same two matrices, okay? This guy is the same thing as this guy. This guy is the same thing as this guy. So we were multiplying the same two matrices, but we switched the order, okay? And notice that order matters with multiplication, okay? I did this matrix times this matrix and I got an answer, okay? But then in part B, I had the same exact two matrices, but I changed the order. In part B, this guy was on the left, this guy was on the right, and that matrix product was undefined, okay? So this is actually showing you one huge difference between matrices and just ordinary numbers. When you multiply two numbers together, like 3 times 4, that's the same thing as 4 times 3. Order doesn't matter when you multiply two ordinary numbers. But in matrix multiplication, the order matters, okay? I just did, if we called this matrix A and this is matrix B, A times B gave me this product. But then if I did B times A, you couldn't do that multiplication. Okay, so that is something you need to be very cognizant of. Okay, matrix multiplication, the order matters. Very, very important. Okay, all right, let's move on to the next example. Okay, so example 7B, where we are still multiplying two matrices together so you can get the hang of this. Okay, so here we go. Here are our two matrices. Okay, first thing we're going to do is make sure we can actually perform this multiplication. So we are going to write down dimensions, okay? This first matrix has 2 rows and 3 columns, so this is a 2 by 3 matrix, okay? The second matrix there has 3 rows and 2 columns, okay? That's why dimensions are so important. You have to be able to write them down, okay? To make sure you can perform the multiplication, the inner numbers need to match, okay? They match, okay? That tells you the number of columns in the first is equal to the number of rows in the second. Okay, we can do the multiplication, and the great thing about doing this is because the outer numbers tell you the result, okay? The result will be a 2 by 2 matrix, okay? So we're gonna have to do a bunch of dot products, and they go in specific places, so you need to plan this out, okay? You're gonna go over here, and you're going to draw out a 2 by 2 matrix, okay? I need something with 2 rows and 2 columns, okay? That way, if you do it this way, where you're mapping it out and you're planning ahead, you won't, you're less likely to lose your place, okay? If you're trying to do this without planning it out, mapping it out, it's very, very easy to lose your place, okay? All right, so let's start. Okay, so again, we wrote down the dimensions, okay? The inner numbers match, which means I can perform this multiplication. The outer numbers give me the dimensions of the result, okay? All right, let's start doing dot products, okay? The way you do it, look at your result, okay? Tell yourself, what position is this? This is the first row, first column, okay? So to do the dot product, you're going to do the first row, first column, okay? So let me start multiplying these guys together, okay? You multiply the corresponding entries, and then you add it all up. So it's going to be 1 times 2 plus 2 times 3 plus 1 times 2, okay? So multiply the first guys together, 1 times 2, multiply the second guys together, 2 times 3, multiply the last guys together, 1 times 2, add them all up, okay? That's what's going to go in the first row, first column, okay? I will simplify at the end, so let's move on, okay? So now let's go to this position. Okay, you can do these in any order you want, okay? This is the first row, second column, okay? So now when I do the dot product, okay, I am doing the first row, second column, okay? So we are going to multiply corresponding entries together, add them up. 1 times 3 plus 2 times 1 plus 1 times negative 1. That's what's going to go in this spot. Okay, so 1 times 3, do the middle guys, 2 times 1, do the third guys, 1 times negative 1, add up the results. Okay, moving on. Okay, in this matrix, this is the second row, first column. Okay, so when you do the dot product, okay, I am going to do the second row, first column. Okay, so this is going to be 3 times 2 plus 1 times, is that positive 1 or negative 1? The bad thing about writing on this is I cover up the signs and I can't tell. Okay, it's positive. Okay, so it's going to be 3 times 2 plus 1 times 3 plus 3 times 2. Okay, all right, so multiply the first elements together. Okay, so 3 times 2. Do the middle guys together, 1 times 3. And then the last guys, 3 times 2. Add them all up. Okay? All right. Last position that we need to fill in. Okay, this is going to be the second row, second column. Okay, so you're going to do your dot product. Go back to your original matrices. Okay, you're going to do the second row, second column. Okay, so we're going to do 3 times 3 plus 1 times 1 plus 3 times negative 1. Okay, so 3 times 3 plus 1 times 1 plus 3 times negative 1. Okay, you're always adding corresponding elements and then adding them all up. Okay, all right, so now we just need to simplify, but this is how you would put it together. Okay, so I'm going to write the answer up here, okay, because I'm going to save some room for this one down here. Okay, all right, so my final answer is going to be what? Okay, this is going to be 2 plus 6 is 8 plus 2 is 10. Right here, this is 3 plus 2 is 5 plus a negative 1 is positive 4. And then 3 times 2 is 6 plus 3 is 9 plus 6 is 15. Okay, and then last position, 9 plus 1 is 10 plus a negative 3 is positive 7. Okay, this is your final answer. Okay, if you multiplied your two matrices together, you end up with a 2 by 2 matrix, 2 rows, 2 columns, and those are the specific elements. Okay, all right, let's try another one. Okay, here's example D. Okay, and these are pretty large matrices. They are both 3 by 3s. Okay, so this one can get a little complicated just because there's going to be a lot of elements here. So you got to be really careful. Make sure you pay attention. You're putting everything in the right place. You're watching your signs. Okay. All right. First thing we got to do. Can we do this? All right. This is a 3 by 3 matrix, 3 rows, 3 columns. This is also a 3 by 3, like I said. Okay. The inner numbers match. These match, which means we can do the multiplication. Okay. The result will be indicated by the outer numbers. Okay, so the result will be a 3 by 3. Okay, so that's going to be pretty big. All right, so you need to map this out so you don't lose your place. Okay, so I'm going to draw something that has 3 rows and 3 columns. Just trying to make it fit. Okay, well that went really well. Let's try this again. Okay. I'm going to have to squinch here. So 1, 2, 3. There we go. All right, so 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, we're going to have to write tiny, tiny, tiny here. Okay. All right, but this is what it's going to look like. Okay. All right, so let's start. Okay. Fill in the blanks. Okay. Here's the first element we're trying to come up with in the result. Okay, where is this located? First row, first column. Okay, so you're going to go to your matrices. You're going to do the dot product of the first row, first column. Okay, so you're going to multiply your corresponding entries together and add them up. So it's going to be 5 times 0 plus negative 2 times 3 plus 1 times 1. Okay, so I'm going to write that down. Okay, so it's going to be 5 times 0 plus negative 2 times 3 plus 1 times 1. You can see it's squunched. Okay, cool. All right, moving on. So I'll go this way. You can, like I said, you can fill in anything in any order as long as you're keeping track of what's located where. Okay. All right, so this next position, this is the first row, second column. Okay, so I'm going to do the dot product of the first row, but now the second column. Okay, so first row, second column. Okay, so this is going to be 5 times 4 plus negative 2 times negative 6 plus 1 times 1. Okay. All right. Then let's do the last element in this row. Okay. This is going to be the first row, third column. So I need to do the dot product of the first row and the third column. So I need to change my column. Okay. All right. So I'm going to have to squinch here. Okay. This is going to be 5 times negative 1 plus negative 2 times 5 plus 1 times 2. Okay, so let me write this down. This is going to be 5 times negative 1 plus negative 2 times 5 plus 1 times 2. Okay. All right, and we can go ahead and simplify this if we want. Okay, and I will. Okay. And then we'll move on to the other two rows. Okay. This is going to be 0. Then this is going to be negative 2 times 3 is negative 6, plus 1 is negative 5. Okay. Over here, this is going to be 20 plus negative 2 times negative 6 is 12. 20 plus 12 is 32, plus 1 is going to be 33. Okay. And then over here, negative 5 minus 10 is negative 15, plus 2 is negative 13. Okay, so you can get some interesting numbers on here. Okay. All right, so that's that. Okay. Let's move on to our next row. Okay, so now we're going to fill in this guy, these 3 positions. This is the second row, first column. Okay, so we need to do our dot product of our second row, first column. Okay, so it's going to be 0 times 0 plus 4 times 3 plus 2 times 1. Okay, so let's write that down. Okay, so we're going to have 0 times 0 plus 4 times 3 plus 2 times 1. Okay, I may just start writing it down here as we go so we don't have to go back to it. Okay, so this is going to be 0 plus 12 plus 2 is 14. Okay, so there we go. All right, moving on. Okay, this is position second row, second column. So you're going to do the dot product of the second row, second column. So change your column. Okay, so this is going to be 0 times 4 plus 4 times negative 6 plus 2 times 1. Okay, so let's write that down. So 0 times 4 plus 4 times negative 6 plus 2 times 1. Okay, so let's simplify. We're going to get 0 plus negative 24 plus 2 is negative 22. Okay, one more entry in this row. Okay, so this is located in the second row, third column. Okay, so we've got second row, change your column. Okay, so do your dot product. Okay, it's going to be 1 times negative 1 plus 6 times 5 plus 3 times 2. Okay, so let me squinch this in here. So 0 times negative 1 plus 6 times 5 plus, oops, I did the wrong thing here. Hold on. I wrote the wrong thing down. It should be 0 times negative 1 plus 4 times 5. I wrote the wrong thing. Plus 2 times 2. Okay, so if we simplify, this is going to be 0 plus 20 plus 4. So it's going to give you a 24 in that position. Okay, 3 more elements to go. You can see how long this takes if you have larger matrices. Okay, all right, in this position, this is the third row, first column. Okay, so now we're going to do the dot product. Let's change these up here. We're doing the dot product of the third row, first column. Okay, so it's going to be 1 times 0 plus 6 times 3 plus 3 times 1. Okay, so let's write it down. Okay, so 1 times 0 plus 6 times 3 plus 3 times 1. Okay, so simplify, this is going to give us 0 plus 18 plus 3 is 21 in this position. Okay, all right, so moving on. Okay, now this is in the third row, second column. Okay, so we're going to do the dot product of the third row, change it to be the second column. Okay, so it's going to be 1 times 4 plus 6 times negative 6 plus 3 times 1. Okay, so let's write it down. We're going to have 1 times 4 plus 6 times negative 6 plus 3 times 1. Okay, let's simplify. This is going to be 4 minus 36 is negative 32 plus 3 is going to be, let's see here, hold on, I lost my place. So 4, that's going to be negative 32 plus 3 is negative 29. Okay, all right, so we got one more spot to go finally. Okay, so this last guy is in the third row, third column. Okay, so you're going to do the dot product of the third row, third column. Okay, so 1 times negative 1 plus 6 times 5 plus 3 times 2. Okay, all right, so let's write it down. Okay, it's going to be 1 times negative 1 plus 6 times 5 plus 3 times 2. Okay, simplify, you're going to get negative 1 plus 30, that's negative, or sorry, that's positive 29 plus 6, okay, is going to be 35. Okay, this is your final matrix.